Hi everyone, in this video we will discuss some of the common programs in Python. Those are all the some basic frequently asked programs and we will do it by using loop. The first program is to find the factorial of a number. As you know, factorial of a number is the number which is the product of all the numbers starting from 1 till that number n. So we will find the factorial of n. So we will accept that number. Now initialize another variable f with 1. This f will store the factorial of n. Now we will take a for loop which will range till n. So we will write for I in range 1 to n. So all the possible values of I are 1, 2, 3 till n. Then for all these values, it will find the product. So f will be f into I. So initially f is having value 1. So in the first iteration, f will become 1 into 1, that is 1. In the second iteration, f will be 1 into 2, that is 2. The third iteration, f will be 2 into, next number is I value is 3, 2 into 3, that is 6. So like this, it will continue. Now at the end of the loop, you will find out the factorial of the given number. Now once you run the program, let's say the entered number is 4, then it will print the factorial is 24. And we'll again run the program, and this time we'll give a different number, let's say 5. Then it will print the factorial of 5 is 120. Now this program is to check if a given number is prime number or not. So as you know, prime number is a number which is having only two factors, that is 1 and the number itself. So what we have to do, first of all, we have to check whether the number is divisible by any of the numbers starting from 2 till the number minus 1. So if there is any number which is divisible by this, that means we can say that it is not a prime number. So how we will proceed? First of all, we have to take the number in a variable n, for which we are going to check whether it is a prime number or not. And as you know, it has to be a natural number. That means you cannot put a zero or negative number in it. So you have to always take a natural number. Now, if n is greater than 1, that means 1 is not a prime number. So we have to check for all other numbers which are greater than 1, because 1 is not prime number. So first condition is if n is greater than 1, then it will check starting from 2 till the number minus 1 whether any number is divisible by n or not. So that we will take in a for loop. So for loop will range from 2 to n. N means actually it will iterate till n minus 1. So let's say your number is 7, then I will have values 2, 3, 4, 5 and 6. So if 7 is divisible by any of these numbers, then it will just there print that n is not a prime number, and it will come out of the loop because we have given a break statement over there. Otherwise, if it will check all the numbers starting from 2 to range n minus 1, and it will not find that there is any number which is divisible by n, then it will come out of the for loop, and at the end of the loop, we have given a else statement. This else is referring to the for loop, which will be executed once the for loop completes its execution. So it will print that n is a prime number. That means it has not found any number in the range 2 to n which is divisible by n. Now in the else part we have written n is not prime. That means if n is not greater than 1. If n will not be greater than 1 means it will be obviously 1, because we have given us measures that you have to enter a natural number. So you should not enter 0 over there. So either you will enter 1 or any number which is greater than 1. So if it is 1, then it will print the else part that 1 is not a prime number. Now once you execute this program, in a first run, let's say you have given a number as 29. So it's given that 29 is a prime number. Why? Because it will first go through the first condition if n is greater than 1. Yes, 29 is greater than 1. So it will check the for loop where I will range from 2 to 28. So it will check any number starting from 2 to 28 whether it is divisible by 29 or not. and it found that there is no number which is divisible by 29 in the range 2 to 28. So it has completed the loop and it has print that n is prime number, 29 is prime number. Then the execution completed. Now in the second run we have given a number as 25. So 25 is not a prime number. So in a for loop, it will come across a number which is divisible by 25. So there itself, it will print that n is not prime number, and the for loop will exit from the for loop because of the break statement. Now the same program is a little bit modified, like write a program to print all the prime numbers within a range. So the same thing, you have to check whether the number is prime or not. So first of all, you have to give a range of numbers so that we will accept through a variable, let's say num. So there you have to enter a number. Then it has to print what are the prime numbers present between 1 to till that range. So for loop will be like this: for n in range 2 to num minus 1, num plus 1, so that this loop will continue from 2 till num. Now for I in range 2 to n, that means for each value of n, it will check whether that is prime number or not. Now I will range from 2 till that number n. So if there is any factor present over there, then it has to break. Otherwise, else it will print that is a prime number. That means if it is a prime number, it will be printed or displayed. So once you run the program, it will ask you to give a range. So the range is like the 15. So it will check starting from all the numbers from 1 to 15. It will check what are the prime numbers present in between. So it will print the prime numbers are 2, 3, 5, 7, 11, and 13. Now the next question is to write a program to check if a year is a leap year or not. So what is a leap year? First of all, it has to be divisible by 4. Like the year 2016, 2020, all these years are leap years. But if it is divisible by 100, then it is not a leap year. Like 2200, 1900, like this. And again, if it is divisible by 400, then it is a leap year, like 2000, 2400, like this. So we have to how to write the program. First, we will check the divisibility with 400. That means if it is divisible by 400, that means it is definitely it's a leap year. Otherwise, it will check whether it is divisible by 4 and 100 or not. First of all, it will check whether it is divisible by 4 or not, and it is divisible by 100 or not. The condition is it has to be divisible by 4 and it should not be divisible by 100. So these two conditions you have to give. So how can you write the program? You can just write enter the year. Now within if condition, you can just give if year is divisible by 400. That is the first part. Or it should be divisible by 4 and not divisible by 100. So either of the condition has to be satisfied so that you can say that this is a leap year. Then it has to print that it's a leap year, otherwise it's not a leap year. The same program we can do by using multiple if statements. So here you can see the first if is having the condition whether year is divisible by 400 or not. If it is divisible by 400, then it will print that it's a leap year. Else if the year is divisible by 4 and not divisible by 100, then it has to print a leap year. Otherwise, it has to print it is not a leap year. So this is how you can just write it in nested if, multiple if. So once you run the program, let's say the first year entered is 1800, then it will print that it's not a leap year because it is divisible by 100. And second run, the year entered is 2020, so it is a leap year. And the third run, let's say the year entered is 2019 and it's not a leap year. And the fourth run, let's say the year is 2400 and of course it is a leap year. Now write a program to print a Fibonacci series up to n. So you can see here, as you know, Fibonacci series is a series of numbers where each number is the sum of the previous two numbers. So if you start your series with 0, Then the first number is 0, second number is 1. Let's say we have to take the first two numbers. Then the third numbers will be 0 plus 1, that is 1. And the fourth number is 1 plus 1, that is 2. Like this, your series will continue till n. So we have to enter the value for n. Now initialize the first two numbers of the series, that is a and b, with 0 and 1. Now just print those two values and just give an end statement so that your next numbers will not be printed in the next line. It has to be printed in the same line so that it will just look like a series. Now our condition is while a plus b less than n, so it has to do some calculation, that is c is equal to a plus b. So C is the third number of the next number, which will be calculated as A plus B. Now A will become B and B will become C. That means second number becomes the first number and the third number becomes the second number. Now it has to print C, that means the third number, because we have already printed A and B, and it has to print the third number C in the loop. And it will continue printing until your A plus B less than N. So once you enter the value for n is 50, that means it will not print any value which is just after 50. So it has to stop before 50 only. So the first two numbers, the series, that is 0 and 1, those are printed. Third number is again 1 because the sum of previous two numbers, and the fourth number is 2. Like this will continue. So as you can see, the steps are like this. The first number A is 0, second number B is equal to 1, and third number C is equal to A plus B, that is 1. Now we have to print C in each iteration. So after that, your A becomes B, that is A becomes 1, and B becomes C, that is B becomes 1 also, and C becomes A plus B, that is 2. Now you have to print C. Now again the next iteration, A becomes B, that is 1, and B becomes C, which is 2. Now C becomes A plus B, that is 3. Then you have to print C. Like this, you have to go on printing till that number that you have given. Now the next program is to print a Fibonacci series up to n terms. Earlier it was printing up to n, but here it will print n terms. How many terms you want, that many terms it will print in the series. The same thing, we have to take that n value, and A and B will be initialized with 0 and 1 respectively. Those are representing the first two numbers of the series. Now it has to print A and B. Now we will take another variable I, which is initialized with 1. Now while I is less than n minus 1, it has to do the same things. That means C will be A plus B. We have to find out the third term. Now your first term becomes the second term, that is A is equal to B, and second term becomes third term, that B is equal to C. So it has to print C, and every time I value will be incremented by 1. So here why we have taken I is less than n minus 1. Why? Because in the series we are already having two terms. First two terms A and B are already there in the series. So we have to print the rest of the terms, that means n minus 2 terms. So to print n minus 2 terms, we have given the condition as I less than n minus 1, or you can give I less than equal to n minus 2, anyway it's possible. Let's say the entered value for n is 9, that means it has to print 9 terms, and the first two terms are already given, that is 0 and 1. Then it has to print the rest 7 terms. So your I value should iterate for 7 times. So I is initialized with 1. So we can give the condition is I is less than n minus 1, that is I is less than 8. I is less than 8 means till 7 it will continue. That means 7 terms, the rest of the 7 terms it will print, because first two terms are already there. The third term is 1, fourth term is 2, like this that you have done earlier. The same thing, like this it will continue till 9 terms. Now the next program is to check whether a number is a palindrome or not. So first of all, we have to take the number. So as you know, a palindromic number is a number which is the same number when you reverse the number. Like for example, 141. If you just read it from right to left, it will also give you the same thing, 141. So those kind of numbers are palindromic numbers. So to check whether a number is a palindrome or not, we have to first of all find out the reverse of the number. Then we will compare that number with the reverse number. Then if you find that these two things are same, then you can say that this is a palindromic number. So for that purpose, let's take the number as input and let's store it in a variable n. Now we will just initialize one variable num with n. That means we will store this value which is entered in a variable, let's say num. Why? Because once we'll process this number by using while loop, then at the end of the loop your n will become 0. Now you can't compare that one. So first of all, we have to store it in a separate variable. So we are storing in a variable num this original number n. Now to store the reverse of the number, we will take another variable rev, which is initialized with 0. Now the condition is that the thing is that we have to extract all the digits from the right. That means suppose the number is 243, then we will extract the first digit, that is 3. Then the next digit, that is 4. The next digit, that is 2. Now what we will do, 3 will be multiplied with 10, that is 30. Then it will added with the second digit, that is 4. It will become 34. And again we will extract the third digit, that is 2, and multiply this 34 into 10 and add that 2 to get the reverse of the number. So we will do that in a while loop like this. First of all, we will take the first digit, that means the digit which is at units place. We will get it by dividing the number with 10 and taking the remainder. Let's say if the number is, let's say 243, then the digit which is at the rightmost, or the units digit, that will be stored in a variable d. So your d value is 3 and n becomes n divided by 10. N was 243, and once you divide it with 10, it will become 24. So n becomes 24. That means the number after reducing the digit from the right side, that is 24. Now reverse will be reverse into 10 plus d. Initially reverse value is 0, so 0 into 10 is 0 plus d is 3. So in first iteration, rev will have value 3. In second iteration, what will happen? D is equal to n percent 10. Your n is 24 now. So D will have the value 4, which is nothing but the second digit or the middle digit. Now n is equal to n divided by 10. That means 24 divided by 10, and the quotient is 2. So we will get 2, that means the number after extracting or reducing the rightmost two digits. So n becomes 2. So your reverse will be rev into 10 plus d. Rev was storing earlier 3. So 3 into 10 plus d, that is 4, is 34. So rev is 34. Also in the third iteration, your d will become 2. Why? Because n percent is 10. N is having value 2. So n percent 10 is 2. And n is equal to n division 10, that is 0. 2 divided by 10, that is 0. And REV is equal to REV into 10 plus D, that is 34 into 10 plus 2, that is 342. So now your loop will stop executing. Why? Because our condition is while n not equal to 0. Now since our n has become 0, so it will stop over there. And finally we'll get the reverse value as 342. So it will check it with the number. We have already stored n in a variable called num. Now your num is having value 243 and rev is having value 342. Now it will check whether these two numbers are same or not. If they are same, then it will print palindrome, otherwise it will print not palindrome. Since they are not same, so it will print not palindrome. Now let's run this program once again, and this time we have entered a value as 54745. So this is actually a palindromic number. That means if you read it from reverse or the right side, then it will also give you the same number. So it will print it as palindromic numbers. Now the next program is to check if a number is an Armstrong number or not. Now what is an Armstrong number? A number which is same as its sum of the digits raised to the power c is an Armstrong number. For example, the number 153. So that is same as 1 to the power 3 plus 5 to the power 3 plus 3 to the power 3. That means 1 to the power 3 is 1, 5 to the power 3 is 125, and 3 to the power 3 is 27. And if you add all of them, then you will get the number as 153. So this is the thing. So how to implement it in a program? First of all, we have to count how many digits are there in this number. That you can do it by using a loop. Now we have to calculate the sum of the digits to the power c. C means the count of the numbers, digits, by using another loop and store it in a different variable. Now compare this original number with this calculated value, and if they are same, then you have to print Armstrong number, otherwise it's not an Armstrong number. Now first of all, we have to input a number which has to be checked. So we have just stored in a variable num. Then c is initialized with 0. C will store how many digits are there in this number. Why? Because all the digits has to be raised to this power of c. So the first thing is to count how many digits are there in this number. Then in the next loop, we will calculate the sum of the digits. So we will take two while loop, and in these two while loops, we will process this number. Then after processing these two numbers, then its value will become 0. So we will just store them in this different variables, that is n1 and n2. So n1 is a variable which is initialized with num, and n2 is also initialized with num. And we will use these two variables n1 and n2 in our loop. So the first while loop, which is used to count the number of digits present in this number. So while n1 not equal to 0, n1 is equal to n1 divided by 10. So n1 will store the quotient once you divide the number with 10. That means if the number is, let's say, 526, then if you divide it with 10, then you'll get the quotient as 52. So your number becomes 52, and count value will be initialized with 1. The second iteration, n1 is not equal to 0, n1 is equal to n1 divided by 10. That means 52 divided by 10 is 5. And a counter value will also again increased by 1. So at the end of the loop, you will get the number of digits present in the number. That means it's a 3-digit number, so its value will be 3. C value will be 3. Now, the second loop, we will extract all the digits from the number, and we will raise the digits to the power c and then find out their sum. And how to do that? We have to take the condition as n2 not equal to 0. Here n2 is also the same as the number, because we've already stored the number in a variable n2. We can't use the same variable n1, because by the end of the first while loop, n1 value becomes 0. So we can't use that one. So we have to use another variable n2, which is also storing the same value number. So n2 not equal to 0, d is equal to n2 percentage 10. That means it will find out the digit which is at the units place. Now your number becomes number divided by 10, and this number will be this digit that you got, that will be raised to the power c. Since here it is a 3-digit number, let's say we have taken a 3-digit number, then it will just raise it to the power 3. That means if the number entered, that is 247, then the first digit at units place is 7, that will be raised to the power 3. And it will be added to a variable arm. Arm is a variable we have taken, which is initialized with 0 to store the Armstrong, the calculated value. So first iteration, arm will store that value. In the second iteration, it will store the value accordingly. So at the end of this loop, we will get the calculated sum of the digit to the power count. Now it will check whether this value is same as the number that we had taken earlier, which is stored in num. So whether num is same as arm or not. If they are same, then it will print it as Armstrong number. Otherwise, it is not an Armstrong number. Now, once you run the program, let's say the first digit entered is 247. So here the number of digits is 3, but it is not an Armstrong number. After calculation, it got some other digit. Now, Let's run this program with another number, let's say 153. Now here it is printing, it is an Armstrong number. Now the next question is to find the highest common factor of two numbers. That means to calculate the HCF or GCD of two numbers. So as you know, HCF of two numbers is the highest number which divides both the numbers. That means the number which is a common factor of both these numbers. So how we will do? We will check all the numbers starting from 1 till the smaller number, and we will check whether it divides both the numbers or not using a for loop. That means suppose if you want to find out the HCF of 12 and 15, then we will take the smaller number which is 12, and our loop will continue from 1 till 12. It will check one by one if any of the numbers which divides both 12 and 15 or not. So if it divides, then we will just store that number. Here we have taken a variable HCF. We will assign that value to HCF, and it will print that this is the HCF. So we have taken these two numbers A and B in by writing the message enter value for A and value for B. So you have to give these two values at runtime. And HCF is a variable which is initialized with 1, which is used to store the HCF of both the numbers. Now the condition will give if A is less than B, then we will take the number as A, or else if B is less than A, that means A is greater than B, then the number will be B, because our loop will continue till the smaller number. So we have to store the smaller number in a variable, let's say num, by giving this condition. Now our for loop will range from 1 to this smaller number. So for that purpose we are given for I in range 1 to num plus 1. Now if I is divisible by both A and B, then that I value should be stored in a variable HCF. HCF will be assigned with that value I. Like this the loop will continue. And if there are more factors which are divisible by both A and B, then the final value of your HCF is the largest value. The last value will be the largest value or the highest value. So it will print HCF is that number. Now once you run the program, suppose the entered value for A and B are 24 and 27, then it will give you the output as HCF is 3. Now in a second run, suppose if I've entered the value for A as 13 and B as 26, then it will give HCF is 13. Now the same program can be done in another way, which is called a division method. In this division method, first we have to divide the numbers. Let's say the first number is divided by the second number and the remainder is obtained. Now the second number becomes the first number and the remainder becomes the second number. Now again do the same division, like first number has to be divided by the second number and the remainder is obtained. And again divide this remainder with the second number. Like this will have to continue until your second number becomes 0. Now the first number that you get, that is the HCF. Like for example, if the two numbers are 15 and 12, then we have to first of all divide 15 with 12 and get the remainder. So that is, let's say 3. Now your first number becomes second number, which is 12. So 12 divided by 3, and you will get the remainder as 0. So your 3 is the value of A, that means that is the HCF. So we will implement that in our program. We will take these two numbers A and B into variables. Now the condition is while the second number is not equal to 0, we will assign A is equal to B and B is equal to A percentage B. So this is a single line assignment where we are assigning multiple values to multiple variables are assigned with multiple values in the same line. So here in the same line, A is having value B and B is having value A percentage B. And at the end of the loop, whatever value will be there with A, that is the highest common factor. Now let's say the values for A and B are 30 and 22. Then it will give you the highest common factor is 2. So what will happen in a first iteration, you can see A is equal to B and B will be A percentage B. So A will have value 22, which is the value of B, and B will have A percentage B, that is 8. In a second iteration, A will have value 8, which is the previous value of B, and B will have value 22% 8, that is 6. Now in a third iteration, A will have value 6, which is the previous value of B. Now B will have value 8% 6, that is 2. In a fourth iteration, A will have value 2 and B will become 0. 6% 2 is 0. So now your loop will stop executing. Why? Because your B has become 0 now. So the final value of A, that is 2. So this is the highest common factor of 30 and 22. Now here ends some of the common programs that we have done by using loop. And if there is any doubt in these programs, then you can put it in a comment section. So these are some of the basic programs that you will be asked mostly or frequently in exams and in the interviews. And so stay tuned for more solutions and do subscribe. Thank you.